When new learners think about authentication in Linux, they often picture one simple moment. You type a username and password, and the system either lets you in or it does not. That is part of the story, but modern Linux authentication and authorization are more like a conversation between multiple decision makers, each responsible for a different kind of access. One decision maker handles how identity is checked and how login rules work. Another handles whether a logged-in user is allowed to perform privileged actions, and another decides how system services and desktops request permission for sensitive operations. If you treat all of that as one blurry concept, it becomes hard to predict why something is allowed or denied, and troubleshooting feels random. In this episode, we build a clear beginner mental model for two key components in the Linux access story: pluggable authentication modules, PAM, and polkit, polkit. The goal is to understand what each one controls, what they do not control, and how they fit together with other pieces like file permissions and administrative privilege. Once you can explain which part of the system is making which kind of decision, access control starts to feel like a set of layers you can reason about rather than a single mysterious gatekeeper. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful first step is to separate the concepts of authentication and authorization, because the words sound similar but represent different questions. Authentication answers who are you, meaning the system needs to verify identity through some method such as a password, a key, or a directory-backed check. Authorization answers what are you allowed to do, meaning the system needs to decide whether that identified user can access a resource or perform an action. Linux uses multiple mechanisms for authorization depending on what is being protected, including file permissions, group membership, capabilities, and policy frameworks. Beginners sometimes expect a single system to manage all authorization, but Linux evolved in layers, and different layers are optimized for different kinds of resources. File permissions are great for controlling access to files, but they are not enough for controlling system-wide administrative actions in a consistent way across many tools. That is why additional frameworks exist, because the operating system must manage both identity verification and permission decisions in contexts that go beyond reading a file. Keeping these two questions distinct is the foundation for understanding what PAM and polkit do. PAM is best understood as a flexible framework that allows Linux to plug in different authentication and account management methods without rewriting every program that needs to authenticate users. Many Linux programs need to check identity, like login services, remote access services, and privilege elevation tools, and without a common framework, each program would implement its own authentication logic. That would be inconsistent and hard to secure. PAM solves this by providing a standardized interface. Programs ask PAM to authenticate a user, and PAM uses configured modules to perform the checks and enforce rules. The word pluggable is important because modules can be swapped or combined, allowing the system to support different authentication methods and policies. For beginners, the most important mental model is that PAM is not a single authentication method, and it is a framework that coordinates methods. It is like a policy-driven gatekeeper that can consult different specialists depending on what the system configuration says to do. PAM is also more than just checking a password, because it commonly includes account rules and session behavior that shape how logins work. For example, PAM can enforce rules like requiring strong passwords, limiting login attempts, or locking an account after too many failures. It can also enforce conditions like whether a user is allowed to log in at a particular time, from a particular terminal type, or under certain system states. During session setup, PAM can help establish environment settings, mount user resources, or run session-related tasks. Beginners often miss this because they focus on the password prompt. But the more accurate story is that PAM participates in the whole life cycle of a login, from authentication through authorization checks related to account status and into session initialization. This matters on the exam because questions might describe a situation where logins are denied even with the correct password, and the reason might be an account rule, a lockout policy, or an access restriction enforced by PAM modules. If you remember that PAM is both authentication and account policy, you will be able to interpret those scenarios more calmly. It is equally important to understand what PAM does not control, because beginners sometimes blame it for every access problem. PAM generally does not decide whether you can read a particular file or access a particular directory, because file access is controlled by file system permissions and related authorization mechanisms. PAM's job is to determine whether a user can authenticate and establish a valid session, and some programs use it for authentication before allowing privileged operations, but the actual access to resources is still enforced by the operating system. This means you can successfully authenticate and still be denied access to a file because you lack permissions. It also means you can fail to authenticate even though you own files on the system, because authentication is about identity verification and policy, not resource ownership. From an exam perspective, the main point is to place PAM in the right part of the story. It is the framework many services use to decide whether to let you in and under what account rules. Once you are in, the permissions you have are governed by other layers that PAM does not override by itself. That distinction prevents a lot of beginner confusion. Now we can introduce polkit, which solves a different problem that becomes obvious in modern Linux environments with graphical tools and service management interfaces. Polkit is a framework for defining and evaluating authorization for certain privileged actions, especially actions initiated by non-root users in desktop or service contexts. Think of Polkit as a policy engine that answers whether a user, who is already authenticated and logged in, is allowed to perform a specific administrative action right now. Those actions might include things like changing system settings, managing services, or performing device-related operations that require elevated privileges. Without Polkit, many of these tools would need to run as the all-powerful user or rely on ad hoc privilege mechanisms, which can be risky and inconsistent. Polkit provides a way to request authorization in a structured manner, using defined policies that can allow, deny, or prompt for additional authentication depending on context. For beginners, the key idea is that Polkit is about authorizing actions, not about logging in. It does not replace PAM, and it sits in a different layer of the access story. Polkit becomes easier to understand if you think about the difference between proving who you are and proving you are allowed to do a particular sensitive thing. You might be logged in as a normal user, and that login was handled through PAM. Later, you try to change a system configuration using a tool that interacts with system services, and the system must decide whether you should be allowed. Polkit can evaluate a policy that says this action is allowed for users in a certain group, or this action requires an administrator to approve, or this action is allowed only when certain conditions are met. In many user experiences, Polkit appears as a permission prompt or an authentication dialog, which can confuse beginners into thinking it is a login system. The reality is that the system is already logged in, and Polkit is performing a targeted authorization check for a specific operation. That targeted nature is the reason Polkit exists, because it allows fine-grained privilege decisions rather than forcing everything into a binary root versus non-root model. On the exam, being able to describe Polkit as authorization for actions helps you answer what controls what. It is also important to see how Polkit fits alongside other authorization mechanisms rather than replacing them. File permissions still control file access. Group membership still influences what resources you can access. Privilege elevation mechanisms still exist for certain tasks, and Polkit can integrate with them by triggering authentication prompts when needed. Polkit's primary role is to provide a centralized policy decision point for actions that are not simply file reads or writes, especially actions mediated by system services that want a consistent authorization model. This helps avoid the pattern where every tool invents its own privilege decision logic, which would be inconsistent and hard to audit. A beginner-friendly mental model is that Polkit is used when an action is controlled by a system service, and the service wants to check whether the requesting user is authorized according to system policy. That is different from a program checking file permissions directly, because the resource is not a file, it is an administrative action. Once you can separate resource types, the role of Polkit becomes clearer. A key exam-level insight is that PAM and Polkit often appear together in the same user experience, but they are doing different jobs. When polkit decides an action requires additional authentication, it may rely on PAM for the actual authentication method, such as verifying a password. That integration can make it look like polkit is authenticating you. But what is really happening is polkit is asking for a policy decision that includes an authentication step, and PAM is the framework that performs the authentication. This is similar to how a security checkpoint might ask you to present identification and then ask whether you are cleared for a specific area. The identification verification and the clearance decision are distinct, even if they happen in one conversation. For troubleshooting, this matters because a failure could be due to PAM rules preventing authentication, or it could be due to polkit policy denying the action even after authentication. If you can name which layer is likely responsible, you can reason about the cause much more effectively. The exam often rewards that layered thinking. Beginner misunderstandings also show up around the idea of who is in control when something is denied. If a user cannot log in, the issue is often in authentication, account policy, or session rules, which points you toward PAM and the services that use it. If a user can log in but cannot perform an administrative action through a system tool, the issue is more likely an authorization policy for that action, which points you toward polkit or group membership. If a user can run a tool but it fails to access a file, the issue is likely file permissions or file system policy rather than PAM or polkit. These distinctions are not about memorizing configuration files, and they are about matching symptoms to layers. Linux access control becomes manageable when you stop treating every denial as the same kind of denial. A login failure is different from a permission prompt denial, and both are different from a file permission error. Once you can recognize the type of denial, your mental map becomes much less chaotic. It is also valuable to connect this to the broader Linux security story because both PAM and polkit exist to make systems more adaptable and more defensible. PAM makes it possible to centralize authentication policy so that many services follow consistent rules, which reduces weak links where one service might have sloppy authentication behavior. Polkit makes it possible to define consistent policies for privileged actions, which reduces the need to run many tools with full administrative power all the time. Both frameworks support least privilege and centralized policy, which are core security principles. They also support better auditing, because decisions can be made in predictable places rather than scattered across custom code. For beginners, the practical takeaway is that these systems are not arbitrary complexity. They exist because modern Linux systems serve many users and many services, and the system needs flexible ways to handle identity and permissions without becoming a patchwork. On an exam, the correct answer often aligns with that architectural intent. When you think about what controls what, a simple and accurate mapping emerges. PAM is the framework many services use for authentication and account-related policy, determining whether a user can establish a session and under what conditions. Polkit is a policy engine for authorizing specific privileged actions requested by already logged-in users, often in contexts mediated by system services. File permissions and file system policies control access to files and directories, regardless of what PAM and polkit decided earlier, because the kernel enforces those rules at access time. Administrative privilege mechanisms govern who can perform high-impact system tasks, and polkit can mediate access to those tasks in a more fine-grained way. When you keep this map in your mind, you can explain most everyday Linux access scenarios without needing to be an expert administrator. The map also helps you avoid a common beginner mistake, which is to assume that passing one check means all other checks will be satisfied. In Linux, access is layered, and each layer enforces its own rules. To conclude, Linux authentication and authorization are best understood as a layered story with distinct components that answer distinct questions. Pluggable authentication modules, PAM, provides a flexible framework for identity verification and account policy that many services rely on during login and other authentication events. PolicyKit, polkit, provides a structured way to authorize specific privileged actions for users who are already authenticated, allowing fine-grained permission decisions and prompts when policy requires additional verification. Neither system replaces basic file system permissions, and both operate within the broader security model enforced by the kernel and system policy. The key exam-level skill is to recognize what kind of access decision is being made and to identify which layer is responsible for that decision. When you can separate login authentication from action authorization and both from file access enforcement, the Linux auth story becomes predictable, explainable, and much easier to troubleshoot with confidence.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.